Hello everyone, I hope I am audible. So, uh, I'm starting a new series. Now, this series is more about me learning things about web fundamentals. So, there is this website, web.dev. Okay, this website is created by Google, and they uh, have these amazing people who they ask to write articles for them. Okay, and these guys are very experienced people, and they write very good article for this platform. The articles is vetted thoroughly, and all the corrections are checked and everything is done, and this is the like one of the best resource to learn anything about web fundamentals. So let me just go to the home page. So if you go to the home page, it looks like this. Okay, and here if you see, there are a couple of courses, like I think total currently there are 4 courses. See, 1 2 3 and 4. But if you go to let's say, yeah, if you go to learn, right, here it's about over here. If you go over here, you can see there are collections. Okay, so there's web vitals, metrics, there are fast load times. Then coming below, there is a section named as build excellent websites. So you can learn about progressive web apps, accessibility, network reliability, security. A lot of stuff is there. Okay, so my uh, aim is to learn this online with you guys on YouTube. I'll see if this is providing any value to you guys, and also if it is providing any value to me also to come online and learn. If it is happening, then I'll continue the series, or else we can see, because I'm going to teach anyways. I'm going to start teaching probably from this Sunday, but I've still not decided whether I will start with JavaScript or React. I mean, ideally, everyone should learn JavaScript and then React, but there is already a lot of resources available for JavaScript fundamentals, but React fundamentals I see very less, so that's what I want to start with. But let's see. I'll decide on Sunday, but that will be a proper teaching session. That will not be me learning. That will be a teaching session. So make sure to join that. Timing and everything I'll update soon on the LinkedIn. But yeah, for today's session, we will be learning about web vitals. Um, so basically, what are web vitals? So Google has formulated 3 important matrices which it uses to measure the performance of your web app. Um, and it can even use this to for SEO algorithm also, like to rank your pages better. So those three are largest contentful paint, first input delay, and cumulative layout shift, CLS. Now I already am aware of these stuff, and I'm aware of quite of what how it works and how can we improve that, but I have never formally learned this. I have just done bits and pieces, and I experimented on my own, that okay, how do I improve this and how do I do that, and I have practically even implemented those stuff. I have implemented these matrices, but I wanted to formally learn this. Okay, that how what does Google want to say about this? That's why I'm learning it over here. I'll be taking notes over here, and if you want, I can share that. But what I would recommend is, whenever you learn, make notes of your own. Okay, so you can then go and if you make your own notes, you will be able to refer it better, and whenever you want to revise, it will be better for you. Okay, so yeah, that's what it is about. So let's just begin. So I just have kept open other learning paths also, just in case I was thinking what should I learn. But I think core web vitals is the one which we should start. Next, I think we can go for security. Security is also a very important part. Okay, and very lesser known part by web devs. Everyone just jumps into React and just starts developing application without caring about security and stuff. So yeah, we should learn that also. But for now, let's focus on the core web vitals. So I have added the link to this website in the description, so you can access it. So yeah, let's begin. Cool. Just in case, let me just check if anyone has joined, because last I checked, no one joined. Um, mm, so yeah, I think yeah, Kit, you are there. So yeah, I think a couple of people have joined, but yeah, soon. Yes, if you guys have anything to ask or anything, you can drop in chat. Soon I'm trying to even make it a Zoom call, like where you can actually join in and talk. But for now, let's. This is what I'm doing. Cool. So let's understand what is Web Vitals. An initiative to provide unified guidance for quality signals that are essential to delivering a great user experience. So yeah, more than performance, it is also about a user experience perspective. Okay, and eventually, why? What is performance? Like if we have a good performing website, that will deliver a good user experience. That's what everything boils down to. When you make app, your aim is to that your user, whoever uses it, has a delightful user experience. So everything that we do is for user experience. So whether you say it performance or you say user experience, I mean technically both are different, but the core web vitals is for eventually for user experience. So let's go over here and see what's written. Okay, optimizing for quality of user experience is key to long-term success of any site, whether you are business or market or some of the things I'll just quickly read through, and if something there's something like it needs to be explained, I'll explain. As an initiative, I'm going to provide unified guidance for quality signals during great user experience. Google has provided a number of tools used to measure and report performance. Some experts are site owners should not have to be performance gurus in order to understand quality of experience. The Web Vital initiative aims to simplify landscape and help sites focus on metrics that matter the most. Core Web Vitals. Okay, so there are various web matrices to measure your performance of web, and we will be going through each of them. But there are three main core Web Vitals where any developer or website maker should focus on. So, yep, the subset of Web Vitals. So Web Vitals are a larger set. Okay, in that we have three core Web Vitals. So we'll be talking about core Web Vitals. Should be measured by all site owners and will be surfaced across Google tools. We'll also be seeing how do we measure this. So that's why I opened Chrome over here, so you can measure how we are going to improve it. Yeah, each of them represents a distinct facet of user experience measurable in the field. So let's just click this. Let's see if we have to learn about this, how matrices are measured. So we'll come back to this if required, but for now let's just continue. Reflects the real world experience of critical user same site, I think. Yeah, the metrics make up core Web Vitals will evolve over time. Yeah, actually recently I had seen in the Chrome developers YouTube in some video that they are introducing two more core Web Vitals. I mean they are experimental currently, but they if that is expected sorry accepted, then we will have 5 core Web Vitals instead of 3. Okay, so those two, I think if I remember, one was responsiveness and another thing was one more thing. So we'll see if it comes, but yeah, currently we are focusing only the 3 core Web Vitals. Yeah, the current set of 2020 focus. Yeah, so that is in 2021 or 2022, which I'm talking about, the two new ones. So currently there are 3: loading, interactivity, and visual stability. Okay, so by loading we mean the LCP, largest contentful pane. How much time does it take for your uh, for the browser to load your website's largest visible element? Okay, now I know what it is, so I'll just brief you about it. So it's either largest image or the largest textual node. Okay, so either of those, whatever is visible first, and when is it visible. So the what is preferred is 2.5, less than 2.5 seconds is good. Between 2.5 to 4 is needs improvement, and after that it's just poor. Okay, so always make sure it your largest contentful paint happens within 2 seconds, I would say. Not don't even go for 2.5, make it within 2 seconds. Okay, how and all we'll see going forward. So that's about loading. Let's go about interactivity. So interactivity, so that the Web Vital is known as first input delay, meaning whenever your website, someone comes to your website and he wants to do any action, let's say he wants to click on a button. So how much time does it take? Like let's say even if your button is visible, if you click, how much time does it take for any reactivity on that? Like even to acknowledge that okay, I have that something is happening. Okay, that's what is known as first input delay. We'll go into a more technicality for going forward, but that's what FID is. Again, 100 milliseconds is good. Between 100 to 300 is fine. More than 300 is poor. Okay, so always have it under 100 milliseconds. Then comes the visual stability. That means cumulative layout shift. Now, layout shift meaning, let's say if you are on a website, okay, and there is an ad banner. So you currently your website is loading, and it's almost like 90% loaded. But in the rest 10%, what happens is the banner comes and your website is like moved or little down. Okay, imagine this is the banner. So currently your website was this, and just suddenly a banner came, ad banner, and your entire view moved down. So that's known as a layout shift. Okay, and you have to calculate cumulative layout shift, like total how much is happening. Okay, like that would be one more, like that could be this, one is this, one could be a side banner or something, whatever it is. So anything that makes your um, web apps page, okay, move up or down from the initial load is known as the cumulative layout shift. So again, it is in the category of visual stability. Your website should be visually stable. Okay, another example would be like if you're clicking somewhere, like some button, and suddenly you get a pop-up, not pop-up but a confirmation message, but that again hides something, or it comes, it shifts everything down. Okay, if common example would be toast. Okay, sometimes people, what they do, they have a toast, and but because of that toast on the above or bottom, it usually above, it shift the entire web down. So that's not good. If you want to introduce a toast, just make it use z index and keep it over it. Don't move your layout. So yeah, that was the gist of it. Now let's learn about it. So largest contentful pane measures loading performance. To provide a good user experience, LCB should be under 2.5, which I already mentioned. Measures interactivity. Okay, this is what I want to tool, so that's nothing new. uh, okay, so I won't click on this because I think going forward we are there in this learning path we have about this, details about this. Now for each of the metrics above, to ensure you're hitting the recommended target for most of the user, a good threshold is the 75th percentile of page load segmented across mobiles and devices. Okay, let me understand what this is meaning. For each of the above metrics, to ensure you're hitting recommended target for most of the users, a good threshold to measure is 75th percentile of page load. Okay, so what I understand is that depending on the different platforms on which your website is going to be used and their network capability, uh, you should target to improve these web vitals on this 75% of your page load. Okay, now I mean, even that doesn't make sense, but let's go for it. It may make much sense, but let's go for it. Let's understand in better. Even I'm a little bit uh, not sure what they're talking about, but let's see. Tools that access core web vitals compliance should consider a page passing if it meets the recommended targeted 75% for all above three matrices. So defining core thresholds. Okay, let's see this, if this gives us some more information about that. Set of matrices. These are the matrices, correct? View 75% view value of page views. In other words, if at least 75% of page views to a site meet good threshold, the site is classified. Okay, got it. So your, let's say your entire web page is 100%. So after of that, even if 75% of that meets good threshold of these three, then it is classified as good. Okay, so it doesn't mean that your entire web app has to be following. Even 75% of it's meeting the requirements of LCP, FID and CLS, then it is recommended as good. Okay, we'll even see how they term it as good, bad and poor. So we'll see in later. Tools to measure Google believes the core evidence is critical to all experience, as it is committed to surfacing these metrics in all of its popular tools. So there are lots of ways to measure. Let's just look at them. um, mm, I think there should be one like table sort of thing. Okay, so it's not a table. So one is Lighthouse. Okay, so Lighthouse is available in your Chrome Dev Tools. So I'll just show you quickly. So if we go over here, let me just open WebDev. And if I go to inspect, If you see here, you can see lighthouse. Okay, so here you can measure the performance. You can check whatever you want, with what categories and what device, and you can generate a report. So that's what lighthouse is. We'll be checking this, but for now just demoing that. Then CRUX, there is one more thing, CRUX, Chrome user experience. So there is another tool. Then there is page speeds. Okay, that's a website. Page speed, page speed inside. So you can just put a URL over here and it will help you measure it. So we just go for web.dev itself. You can click on analyze. Why nothing happening? Weird. Okay. That was a bug, I think, but fine. Uh, so meanwhile it gets generated. Okay, it got it. Okay. So here you can see FCP is 1.9, so it's less than 2.5, so fine. FID is 14 milliseconds, which is awesome. Like it should be under 100, so 14 is very good. Sorry, this was not LCP, it was FCP. My bad. LCP is 2.3, which is fine. FCP is another vital, web vital, but not a core web vital. We'll learn about this later. And then comes CLS 0. There is no cumulative layoffs. Okay, great. In terms of performance, overall is 77%. I mean, it's a Google's website with 79 performance. You can increase, anyways. Um, so these are other ways to measure it. Speed index, LCP again. Time to interactivity. So time to interactivity comes factors in FID also, right? So we learn about that when we even dive dive deep into the FID, that TTI factors into FID. Total blocking time, cumulative layer shift 0, which is great. And they will also tell what environment have they emulated in. So it's Moto G4. Okay. And slow 4G throttling. So it's in network type is slow 4G. How you can change, if you want to do that, you can go to inspect, go to network, your throttling you can change fast 3G, slow 3G. You can even add custom. Okay, so how much kbps or upload download you want, how much latency you want, you can do that. If you know your users what on an average how much is their platform capability, you can do custom also. So and they even say what you can improve. So opportunities, reduce unused JavaScript. Okay, so you can defer the script until unless someone uses it, like someone requests for it. Let's say some part of your web app is on another page, but you're sending the JavaScript in the first page itself. So we should not do that. Unused CSS, same. See, there are a lot of things, but we'll focus on core web vitals. So yeah, this is just a demo of that. Going to desktop, FID is 3 milliseconds. That is smooth. We're like 3 milliseconds. LCP 1.3 and CLS 0, which is obvious. Here they have not given proper details. Various network, various desktop devices. Fine. And 100% performance. Great. So for mobile it's 77, but for web it's 100%. It's good. Good, not it's awesome. Okay, here they have mentioned custom throttling. So I told, right, if you can go to the dev tools and add custom. So they have added custom over here. If you check the information, they have mentioned the kbps and the, I think this is the latency. Okay. Here they have just mentioned CPU power, not any type of device as such. So again, opportunities and stuff is there, but overall like performance is 100%. So it's just amazing. Great. What is this? I need to check. There's some difference. We'll see what is this origin. We'll learn about it. But yeah, for now, let's continue on our article. So various tools. The one is Lighthouse, one is CRUX, one is the page insights, and there are a couple of more, but we'll learn about it later. The Chrome User Experience Report collects anonymized real user measurement data for each core web vital. This data enables site owners to quickly access their performance without requiring them to manually instrument analytics on their page. And powerful tools like Page Speed Insight and Search Console's core web vital report. Okay. So these different ways where you can measure the core web vitals. So they are just saying that these are different tools which measures all of these: LSCP, FID, and CLS. They tick mark over all. So these you can use any of these to measure. Currently, we use Page Speed Insights. For which tool is right for you, getting started with measurement. So if you want to know which is right for you, then you can do. My suggestion would be, if you're developing locally, okay, so or in always don't measure your performance when you're running the server locally, meaning let's say you're developing a React app. Okay, so when you are doing npm start, don't measure that. Build your website. So that will be build command, npm build your website. Okay, and then open the index.html, and then you start measuring it. Okay, using the this thing, Lighthouse tool. Don't do it on the server. You will not get proper data. And another, if your website is already deployed, then use this page speed insights. So that's what I do. Measure core web vitals in JavaScript, and each of core web vitals can be measured in JavaScript using standard web APIs. Easiest way to measure all core web vitals is to use the web vitals JavaScript library, a small production wrapper. Yeah, so even an npm package is also available for core web vitals. So if you go to npm core web 3, let me just search for that. Core web vitals. So gets named web vitals. So you can use this npm package also. You can import it in your app, and you can use this. You can learn about how to use it using this guide. Okay, you can just do this. Great. Get LCP, get FID, get CLS. And also, if you are using Create React app, then they provide by default, okay, for you to measure the core web vitals. Let me just check if I can show you that. Okay, here it's not mentioned, but maybe it's just recently added, but I remember, so it's there. You have one core web vitals where you can, just like this, you can add console.log in that, and they will log all the, they will show you in the console all the different parameters. Yeah, so you can read this documentation and try to use it in your app. Okay, let me just check. Where are we? Yeah, so JavaScript library. So what are they saying? There's GitHub repo for web vitals. I think this is the, so you can use this. Yeah, same thing from npm. Same. So you can use this to measure. If you want to programmatically measure, then you can use this. Small production, as simple as calling a function. And you can even do to send it to Google Analytics. So let's say you have enabled in your Google account analytics, so you can even do that, send to analytics. So that's also a good way to measure your production websites performance. Once you have configured your site to use this library, and send your core web vitals data to analytics endpoint. The next step is to aggregate and report aggregate and report the data. If your pages are meeting recommended for at least 75% of page visits. Yeah, so basically what you can do, basically different people will be taking your website, right, on different environment, on different processing power. So some will have a good laptop, some will have average laptop, some will be doing on phone, some will be doing on tablet. Again, on phone and tablet, what sort of network they are using. So you can aggregate that data. Okay, you can sort of summarize or aggregate the data and try to understand, try to see uh, how you can improve. Okay, and you can even check what sort of users are heavy, like slow 3G correction, mobile people or laptop with fast Wi-Fi. You can even see that, and you can try to then, according to your demographic, you can try to improve the web vitals. Analytics provide the built-in support for Google metrics, even those that don't should basic custom metric features that allow you to. So some of the analytics do provide it. So yes, I just mentioned Google Analytics, right? But there are other analytics platform also which you can use, and some of them will provide built-in, but otherwise you can customize it, and it will allow you to measure core web vitals. Okay, now this is just data. I'll just read through it. Nothing much. You can also code using web vitals. So there is an extension also. So you can use the web vitals extension also. So again, it measures all these things. LCPFIDs, yes. Who prefer to measure these metrics directly via underlying web APIs can refer to the metrics guide. So let's see. Okay. So if you want to directly use your Chrome's web APIs, underlying web APIs to measure the performance, then this is the code for it, and you can use this. Okay. So they have provided code for each of them. LCP, FID, and CLS. So no need of any tool, no need of any library or anything. Pure JavaScript. You can just make sure whether whatever you are using is available in all the browsers that your customers are using. Otherwise, it will not work, or have the polyfill for them. But yeah, this can be used if you directly want to use the core web APIs, browser APIs. Labs to measure core web vitals. Chrome Dev Tools, Lighthouse. Yeah, so I told, right. FID is not. So FID is very much dependent on time to interactivity. So, and another part of it is also TBT. So I think it's a first byte or time to first byte or something. Total blocking time. Sorry, total blocking time. So you can use TBT instead of FID if you use Lighthouse report. But I think this block may not be updated because recently I did see that being in there. Okay, I was using performance tab, not this. Okay, so there is one more way. Okay, performance tab where you can click this web vitals and measure it. So I'll show you that also. So yeah, if you use Lighthouse, then you cannot get this. So if you want FID details, then you can try to use the page speed insights, I would say. Yeah, this. Tool like Lighthouse that loads pages on simulator without user cannot measure FID. There is no user input. However, total blocking time metric is lab measurable and is a yeah. So there are two things which is very important. One is testing in lab and testing in actual production. So lab meaning nothing, not special lab. Testing on the developer's laptop is what is known as lab, where we actually write the code. So that will always give a little different data than the actual production data. Okay. So sometimes what we do, we try to figure out the performance details based on our laptop, and usually if you know developers have a very high config laptop, right? So they don't even have to do much for optimizing performance. So if you do based on the lab data, okay, even with throttling and stuff, if you do on your lab data, if you try to improve your core web vitals, what will happen is that users will not have that perceived performance improvement. Now what is perceived performance improvement? So meaning you have improved on the numbers. You can see that earlier it was this, let's say earlier it was 3.5 seconds, and now the LCP is, let's say, 1.5 seconds. Number wise you are saying okay, it's improved on your lab. But when the user is going to use it, if he doesn't feel that there is an improvement, actual user doesn't feel the improvement, so that is known as user perceived performance, then there is no point. Your number don't mean anything. Okay, so try to uh, make sure that once you are done improving your performance, whatever numbers are there, numbers are fine, but you should also take feedback from the actual users who are using it. So yeah, that's another thing. And the lab and prod that I told, it lab is where your development happens, and prod is actually when you are deployed. So yeah, they have mentioned here. So that's why the reason for not having FID is that there is no user input. So that's why in lab, in your lighthouse, which is our Chrome DevTools, we don't have FID. mm. While lab measurement is essential part of delivering great experience, it is not a substitute for field measurement. Okay, so lab is known as our desktop, sorry, our development environment, and field is the production. The performance of a site can vary dramatically based on users' device capability, their network conditions, what other processes may be running on the device, how they are interacting with the page. In fact, each of the core web vital metrics can have its score affected by interaction, which all we all know. Like all of these parameters, can affect these scores. So only field measurements can accurately capture the complete picture. Okay, so actual users only can do it. Recommendation for improving the score: once you measure score web vitals, identify the areas of improvement. Next is to optimize it. The following guides are for optimizing, so we'll go to over it, but first let's understand each of the web vitals, which will be, I think, in the next page, I hope. Now, what are the other web vitals? While core web vitals are the critical ones for delivering, okay, boxes. These other web vitals often serve as a proxy or supplemental metrics to core web vitals and help capture larger part of the experience to aid diagnosing a specific issue. For example, the matrix time to first byte. Yeah, I actually was measuring this when I saw TBT. That was total blocking time. So time to first byte and first contentful page are vitals, both vital aspects of loading experience. Okay. So time to first byte, I think from name you can see uh, how much time does it take for the first byte to receive, I think, from the network. Let's just confirm this. Metric that measures the time between the request for a resource and when the first byte of the response. So yeah, so let's say you hit web.dev. So now what web.dev, it will it will go to that URL and it will hit the API, and it will wait for the resource. So let's say HTML page. So the time between you hit enter and that request happened, and the HTML page was returned to the browser, that is known as time to first byte. Okay, so yeah, this given in here in detail. So let's say you hit enter, let's say it was redirected, it saw in the cache, so it was not available in the cache, the DNS, TCP, request, response. Okay, so then it comes the time to first byte. Okay, which is time between start time and response start. So start time, which is this, and response start, the time between this, okay, these is known as the TTFP. Okay, then let's learn about first contentful pane also. I'm not going in depth of these two because these are just web vitals, not core ones. So first we'll focus in depth with core web vitals, and then we'll come to FCP and TTFP in depth. Measures the time from when the page starts loading to when any part of the page content is rendered on the screen. Okay, so even the smallest UI, okay, which is visible, and they are given here content meaning text, image, including background image, SVG, any non-white canvas elements, anything. Okay, any one of this which is visible on your screen first, after your browser has received the HTML and it's started parsing, whatever the time is there after the browser started parsing the HTML, and what after you can see any content on your web page, that's known as your first contentful pane. From the name itself, it's very clear. First contentful page. Okay, and what does content refer to? So these are the things which it refers to. Good. So this is again very important for loading experience. Again, we saw there are three main categories, right? Loading experience, and visual stability, and one more was there. Well, I forgot it, but yeah. So these three are the categories in which these are bifurcated. What is the diaggregation with LCP? So resources buckets per activity. Yep. So these two also help us diagnose these issues with LCP. So once you know LCP is low, you can measure these two and try to understand, okay, why is the LCP low? Okay. Similarly, metrics like TBT, total blocking time, and time to interactivity are lab metrics that are vital in catching and diagnosing potential interactivity. Yeah, so this was the one that I was not able to recall. Loading experience, interactivity, visual stability. These are the three categories in which different web vitals are bucketed. However, they are not part of core web vital set because they are not field measurable, nor do they reflect user-centric outcome. Okay. So the reason that these are not part of the core web vitals because they are not field measurable. So in production they are not measurable. I'm not sure why, but uh, maybe, and they do not reflect a user-centric outcome. Okay, cool. So let's see about TBT. Again, it's a very important lab metric. It's total blocking time metric measures the total amount of time between first contentful paint and time to interactivity. Okay, so this sort of recursion. Let's learn what's time to interactivity. Measures the time from when the page starts loading to when its main sub resources have loaded, and it is capable of reliably responding to user input. Sort of, I got the idea. So once your page has loaded, okay, and if you click something, then you can see, okay, it's responding. If you click or scroll or anything, basically any interaction with your web page should give a proper response to the user input. So that is what it is. So it starts at FCP. Okay, here it says navigation start FCP TTI. Okay, let me just check again. To calculate TTI based on performance trace of a web page, follow these steps. Start at FCP. Okay, so FCP, whenever once your first contentful paint is happening, search forward in time for a quiet window for at least 5 seconds, where quiet window is defined as no long task and no more than 2 in-flight get requests. Okay, search backwards for the last long task before the quiet window, stopping at FCB if no long tasks are found. TTI is the end time of the last long task before the quiet window, or the same value as FCP if no long tasks are found. Okay, cool. This is a bit complicated. Start at FCP, which is clear. It starts at first contentful paint. Search forward in time for a quiet window of at least 5 seconds. So we have to search for in time for a quiet window of 5 seconds. And what does a quiet window mean? So they have defined quiet window over here. No long tasks and no more than 2 in-flight network GET requests. So let's see what long tasks is that is blocked for long enough to affect the frame rate or input latency. Okay. So long task is anything that is blocking the thread as such. So okay, this is long task. It takes less than 5 seconds. Okay. So I think 50 milliseconds is the measure. Like if any task takes more than 50 milliseconds, that's a long task. If it takes less than 50 seconds, then it's a short task. So search forward in time for a quiet window of at least 5 seconds. Okay. Where quiet window is no long task, no more than 2 infinite networks. Search backward for last long task before the quiet window, stopping at FCP if no long tasks is found. So 1 is this, 2 is still here. Okay, so it went ahead in forward. Here it is some, there is some long task. Here there is some long task, but here the long task stops. Okay, so then we find the 5 seconds window, which is this, I guess, and then search backward from here. Search backward for the last long task. So this was the last long task, right? Before the quiet window, stopping at FCP if no long task. But we have this long task, so we are not going out to FCP. Otherwise, we would have gone to FCP. TTI is the end time of the last long task before the quiet window. Okay, so this is TTI. So it was a bit of a calculation we need to do, but I think finally I think we have a hang of it. Starts at FCP, so it will, this is one. Search forward in time for a quiet window of at least 5 seconds, where quiet window is defined as no long tasks. Okay, and no more than 2 in-flight get requests. So here going forward, okay, here there is a long task, here there is a long task. So here finally, once this second long task is done, we get a 5 seconds window. So when that 5 seconds window ended, from that we go back. This third, search backwards for long task before the quiet window. Okay, so before the quiet window, which was the long task, this or this one. So, and if this both were not there, we would have stopped at FCP. Okay, so TTI is the end time of the last long task. So this was the last long task. So that's the end time of this, which is this. So fine, that's fine. Cool. Bit tough, but yeah, yes. Similarly, matrices like TBT and TTI are libraries for interactivity. Cool. Web Vitals and Core Web Vitals represents the best available signal developers have to today to measure quality of experience across the web. But these signals are not perfect, and future improvements or additions should be expected. Yes, as I already told, there are 2 more coming in, so you can expect those. I think this is the place where it will mention it. For now, only this. Fine. Core Web Vitals are relevant to all web pages and featured across relevant Google tools. Changes to these metrics will have wide-reaching impact. As such, developers should expect the definitions and thresholds of core web vitals to be stable, and updates to have prior notice and predictable annual cadence. The other web vitals are often context or tool specific and maybe more experimental than web vitals, core web vitals. So always, like, what they are saying is focus on your core web vitals. If you try to improve them, then you will have a larger impact. Okay. Cool. All articles. The business impact. Okay, I think this is a case study. I can ignore the case studies. Basically, these are case studies where people have actually tried, got some good business results after improving on their core web vitals. So if you see here, Vodafone improved LCP by 31% to achieve 8% more sales. Okay, so basically they are converting the improvement in performance to improvement in their business, improvement in their profits. Okay, see here, iCook improved CLS by 15% to achieve 10% more ad revenue. See, Tokopedia improved LCP by 55%. Wow, this is amazing, more than half, like half. So, and saw 23% better average session duration. Cool, great. Again, Redbus CV fixes contributed to 80% mobile. I'm not sure what this CV core web vitals. Okay, fixes contributed to 80 mobile conversion rate. Okay, so core web vital fixes, not, they are not mentioning which one, but core web vital fixes contributed to 80 to 100% mobile conversion rate. Wow, nice, great. Yes, okay, read these case studies if you want. We'll just dive deep into LCP. Now, before I dive deep into LCP, let me see if there's anything in chat, because I have not monitored the chat. Okay, so there are 2 messages. One, actually, I should check it earlier. Sorry about that. Apu, can you share how it industry performance is locked so that we get to know, compare our performance improvements? Okay. Let's say I hosted an app on Heroku. Can I use all of these there? Yep. So, Ankit, in industry, so what we do is we use any of these tools, okay, uh, to either have it locally, or if you want best practices, then what you should do is that um, use the JavaScript npm API, which is Web Vitals, and in that use any of the analytics. So, for what I know is one of the services in your Azure that provides for analytics, so we can directly log over there. So here, what you're doing is, right, this thing you're put your basically this is like a standard output where you want to output this. So here this is console log. Instead of that, put your analytics API. So though then these vitals will be recorded in your analytics API, and you can see it in your dashboard, Azure dashboard or AWS dashboard. I am sure AWS also will be providing something for analytics, but I'm only aware about Azure. So in industry, this is how we measure it. We use the APIs, okay, and then we measure it in the our analytics tools, and then we can from there we can that analytics tools are awesome, so we can get graphical representation and all those stuff. So yeah, that's a good question actually. How we measure it in industry. Second one was, let's say I hosted an app on Heroku. Yeah, so same thing, you can use just use that deployed web app and go to the page speed and just put the URL over there, hit enter, you will see whatever the result is. Okay, that's the easiest way of doing it. Otherwise, if you want to do like this, you can do this, but you need to then have some analytics software. Try for free one. I think Google Analytics should be free, at least for that 1 year trial or something. Even Azure for 1 year it should be free. You can search for it. I'm not sure about the charges of it, but if you want to do like this, you can do like this, or you can, if you're developing on your own and not for industries, then I would say just go for page speed website. And if your website is deployed, just go mention the URL over there, hit enter. That's how you will see. Okay, cool. We have only, so I'll just wrap it up in 10-15 minutes, but I think we can talk about LCP. Important user centric metric for measuring perceived load speed. I told, right, perceived. What does that perceived mean? Means user should know actually that something your user should know that it's performing well. Otherwise, there's no uh, importance of improving on the just numbers, because it marks the point in the page load time when the page's main content has likely loaded. Likely, I mean, not 100% sure, but likely that's the main content. A fast LCP, because that's always contextual, right? What your main content is on your web page. A fast LCP helps reassure the user that the page is useful. Yeah. Mm, has enough content rendered that the user can start engage with. So is it useful? Wow, everything is mentioned over here. This is just amazing resource. What do they mean by page is useful also is mentioned over here. Great. Has enough content rendered that the users can engage with it. Great. Historically, it has been a challenge for web developers to measure how quickly the main content of a web page loads and is visible to your users. All metrics like load or DOM content loaded are not good because they don't necessarily correspond to what the user sees on the screen. Yeah, these are some of APIs which can be used to measure your when the web page is loaded and when the DOM is loaded and all those stuff. But it's like you are measuring the code, like you're measuring the code. You're not actually measuring what the user is seeing. So you are just seeing like the DOM tree was loaded properly or not, or is loaded or not, something like that. But if you want to actually measure that on visually, whether it's appearing or not, then it was not good for that. Newer user-centric performance metrics like FCP only capture the very beginning of loading experience. If a page shows a splash screen or a display loading indicator, this moment is not very relevant to user. Yeah. So why is not FCP part of the core web vitals and why is LCP? Because of this reason, like you will have some splash screen. So splash screen is like if you load any app, mobile app, you will see like some sort of animation. While basically it's a loading indicator, right? Where boot up. Basically, whenever your mobile app is loading, it will show you some interactive, some splash screen, so that you know, okay, it's loading. And if it's a web app, there will be some sort of loading indicator, some sort of, you can make it as fancy as you want, but still your website is not usable, it's just loading. And hence FCP is not the true measure for it. Okay. LCP is. In the past we have recommended performance metrics like first meaningful paint. So let's see what is FMP. One more thing. First meaningful deprecated. Okay. Overly sensitive small differences. Okay. So just caution, FMP is deprecated. Moving forward, consider using LCP. Okay, so first meaningful paint is one of the 6 metrics tagged in performance section. Excuse me. When the primary content of the page is visible. Okay. How do you know what is the primary content? FCP and FMP are often the same. Okay, so let's say there is an iframe and there's content available in the iframe. FMP registers this, but FCP doesn't. Okay, but overall it's almost similar to FCP, but it's deprecated, and instead we should look for LCP. Okay, so yeah. In past we have recommended performance like FMP and speed index, both available in it's currently deprecated, but yeah, to help capture the more of loading experience, let's see what's the speed index. Speed index shows how quickly the contents of a page are visibly populated. A lot of these are like very coinciding, like a lot of these metrics are coinciding, but let's see what's the minute difference. Index measures how quickly content usually captures the video of the page loading in the browser and compute the visual progression between the frame. Speedline node module to generate speed. Okay, so it captures a video of page loading in the browser and computes the visual progression between the frames, and then uses one node module to generate that score. So that's what a speed index is. And ideally it should be anywhere between 0 to 3.5. This is I think not deprecated, so you can still use this to measure your performance. Help capture more of loader experience after initial paint, but these matrices are complex and hard to explain. Yeah, how to explain would be the one TTI, right? Time to interactivity was the most hard to explain. Often wrong, meaning they still do not identify when the main content of the page is loaded. Sometimes simpler is better. Based on discussions in WC Web Performance Group, research done at Google, we have found that a more accurate way to describe when the main content of a page is loaded is to look at where the largest element is rendered. So they have done a lot of research, a lot of discussion, and based on that only they have arrived to this conclusion that instead of using FCP, FMP, speed index, all of these, it's better to measure it using the looking at the when the largest element is rendered. Okay, so LCP matrix reports the render time of the largest image or text block. I already mentioned this in the starting of the video, right? Largest image or the text block visible within the viewport. So you don't have to scroll for it. Within the viewport it should be visible, relative to when the page was first started loading. Okay, so we'll look at this part, but first let's see image or text block. What does it mean? What elements are considered? As currently specified in this API, types of element considered for LCP are image elements, images, elements inside the SVG like SVG, video elements, an element with a background image loaded via URL function as opposed to CSS gradient. So CSS gradient will not be, a background image with CSS gradient will not be counted, but a background image with URL will be counted. A block level element. So you know what a block level elements, right? So let's be clear on that also. So there is inline and there is block. So block is meaning they occupy the entire width and they start on a new line always. And inline meaning they start on the same line and they only occupy the width which is according to their content. Okay. So block level elements containing text nodes or other inline level text elements. So block, within block there can be inline. So let's say there is a Now I don't know whether p tag is a block level element. Let's assume if p is a block level element, then within that, if there are span, then that's fine. But it has to be a block level element, and it can be text node, or can contain another inline elements within it. So these are the elements which can be used to identify the um, largest contentful pane. So image img tags, image elements within svg, video elements, and an element with a background image with url, not css gradient, and block level elements. To limit such as intentional to keep the things simple at the beginning, additional elements may be added in future as I mean, they are already added. Anyways, let's close this, go back. So LCP metric reports render time of the largest image or text block visible within the viewport relative to the when the page first started loading. What does it mean? Okay. Time origin must be the return value written by get time. Time origin attribute must be return value of the get time origin step for relevant. Okay. Okay. In window context, it represents the time when the navigation has started. Okay, cool. So what is a good LCP score? We already know it's less than 2.5. To ensure rating this target for most of the users, a good threshold is 75th percentile of page loads segmented across. Okay, so on an average, so earlier I think I mentioned it wrong. So it's like 75% of all the user data, like 75 percentiles of page loads segmented across mobile and devices. So let's say 100 people are using your web app. So at least for 75 of them, okay, it should be less than 2.5. That's what it means. Now I'm 100% sure what 75%. I mean, earlier I confused it as like page ka 75%. That was wrong. Cool. Learn about the research and methodology behind this. You can refer to this defining core web vital thresholds. We can go to that once we're done with all the this stuff. What elements are considered? Yeah, we already went through this. How is an element size determined? Size of an element reported for LCP is typically the size that visible to the user within the viewport. If the element extends outside of the viewport, or if the element is clipped or has non-visible overflow, those portions do not count. Okay, so like if you have like overflow hidden, or your the entire um, image or whatever it is, it's getting cut off and it's like below the viewport, okay, then they will not be considered. So let's take an example. So let's say this year, currently this is our, based on this viewport, this is our LCP. But if you see here, there's an image, but that's getting cut off. So if I go over here, then this would become LCP. But at this point, this is not an LCP. Just I'm giving an example to help you understand what is mentioned over here. Okay, for image elements that have been resized from their intrinsic size, the size that gets reported is either the visible size or the intrinsic size is smaller. For images, image elements. Okay, it's already 10:04. So we'll start from here from next time. How is an element's size determined, and then we'll continue. But for now, let's stop over here. It's already about time. Let me see if there are any other questions. I think not, but yeah. So I've answered all those questions. Cool. So I personally enjoyed this because I was 100% focused on learning. I haven't. It's very rare that I'm 100% focused on learning, because I'm also online, and I know that someone is watching my screen and watching someone. So I like this way of learning. Even if people don't attend, I think I can continue this. But let's see. Great. I learned a lot. I hope you did too. And if there are any doubts or anything, you can reach out to me later also. If you are watching this video later, this live stream afterwards, if you are watching this, do comment if you have any doubts, or if you want to mention anything that I mentioned wrongly, you can definitely correct me, because even I'm learning. So yeah, and I hope to see you on the Sunday. I'm not sure if I start with JavaScript or React, but I'll definitely start with something. But that will be pure teaching. Okay. So cool. I'll see you on Sunday. Bye bye.